Alright guys, so we are going to talk about the perpendicular bisector now. So, as we look here, the part of the standard we're going to talk about is points on a perpendicular bisector of a line segment are equal distance, are exactly those equal distance from the segment's endpoints. So, what you're going to review is what a perpendicular bisector is and what happens when a perpendicular bisector intersects a line segment. I'm going to explain what both of these are, what a perpendicular bisector is and what a line segment is. So let's go ahead and talk about it. What happens when a perpendicular bisector intersects a line segment? So let's draw a picture. So here's the line segment, and I'm going to call it A, B. And then I'm going to draw a perpendicular bisector through line segment A, D, and I'm going to call this C, D, right here. So what I do know, a perpendicular bisector, and the midpoint here I'm going to call P. So what a perpendicular bisector is it crosses line segment AB at a 90-degree angle, and at the midpoint P, it splits the line segment in half. Alright, so there are some characteristics about this you need to know. That if I choose any point on this line segment CD right here, then it will be equal distance from this line segment. So if this is 10 over here, then from D to B is 10 also. If from A to C is 7, then from C to B is also 7. Alright, so that's a perpendicular bisector crossing over a line segment. I'm going to draw this the other way. So I'm going to make my line segment be vertical, and I'm going to call it E and F. And I'm going to make my line be horizontal and call it A and B in this case. So what I would find out is any point on line AB would be equal distance from A to F as would be from F to B. So let's say if I dropped another point on here. Let's say if I put point K here and point L over here. And I'm going to go ahead and put the midpoint right here, because this line EB is a perpendicular bisector. So that means this is 90 degrees, this is 90 degrees, this is 90 degrees, this is 90 degrees. And the line segment is split. You can't actually find the midpoint of a line because a line is infinite on both sides. It doesn't stop. But you can find the midpoint of a line segment. So if I know that this side is 5, then the other endpoint on this line would also be 5. If from K to E is 6, then from K to L would also be 6. So just be careful on which part is the line and which part is the line segment, and you should be good with this concept. Alright, so let's work this problem out with the knowledge that we just got. It says that find X, and then it wants us to find EB. So we're going to look here and see. So based on this picture right here, is showing us that this is a perpendicular bisector because it's crossing this point, this line AB, at a 90-degree angle. And if you see these other marks that are there, it's telling you that this piece is equal to this piece. So I have an endpoint here and an endpoint here. So if we look, AB is my line segment. So if EA is 5x, then EB should also be 5x. So if AE is 5x, then EB should also equal 5x too. And it wants me to solve for x, so that's not helping me solve for x. But if I go down to line segment AB, I see that 2x plus 4 should equal 3x. Okay, so I should be able to find x, and then I can go and find the value of EB. So here I'm going to subtract 2x from both sides. We're going to get 4 equals 1x, divide by 1, divide by 1. 4 equals x. So we found x. Now I can go back and find this piece right here that they asked us to solve for, EB. This right here. So that means that EB equals 5 times the 4 we found, and this is 20. So x is 4 and EB is 20. And we did it. Alright, so go ahead and go through, knock out the rest of these problems on your sheet, and I'll talk to you guys in class tomorrow. Bye.